Hello! I am going to do my best job of a review note. I'm apologizing well in advance, I hope, because I'm using this technology for the first time this way ever. So I just killed 20 seconds with an apology. Anyhow, we're going to start Unit 1. It depends on a bunch of stuff you learned in grade 10 and 11. There may be one topic in this note that might be review, and I apologize again for my ums and ahs. I'll get through this as quickly as possible, which probably isn't quick. A reminder that at any time you can pause if you choose. I advise you to pause right after I'm done this particular topic factoring and before I go on to the next slide. So if there's a little cursor yellow highlighty thing over top of this, sorry, I don't know how to get rid of that either. I am going to start this. So these are the 8 questions we're going to look at. I'm going to give myself a little bit of room. So this is where you might see the yellow highlighter thing. Something I'm going to go through is what kind of factoring this is. It's super important that you learn factoring well or relearn factoring well because it is something that you're going to see throughout every single unit of this course. So I can't remember if that's 7 or 8 depending on how I break it up, but it's pretty important. So this is me with the new technology now. So, all right, so the first question is this. And I want you to see that it's a trinomial, meaning that it's got 1, 2, 3 terms. It actually has the 2 x squared, so a degree of 2, a degree of 1, a degree of none, so 2, 1, none. That makes it a possible trinomial. It's a simple trinomial because it doesn't start with a number. So when we get there, this is another simple trinomial. It looks an awful lot like this one, only I did a little sign change. This one, to begin with, because it's got a 2, looks like a complex trinomial. And this, because it starts with a 6, looks like a complex trinomial, but isn't necessarily the case. I will go over that when we get there. So with this particular question, we need to start with x and x, because if you were to FOIL this out, you would have x times x is x squared. Then you are to find 2 numbers that have a product, so multiply, to be the positive 6, and at the same time either add or subtract to be the positive 5. So the only 2 numbers that work for that are positive 3 and positive 2. For the record, reminder from grade 11 or grade 10 is if you have the exact same brackets as me, but in an opposite order, it's still good. You can't have positive 6 and negative 1 because although that does make positive 5 when you add or subtract them, it doesn't make positive 6 because a positive multiplied by a negative would be a negative 6. So if we go on to the next question, like I said, it could be a complex trinomial, and it actually is a complex trinomial. The reason being that 2 doesn't divide into the other 2 terms, which means you can't remove it, so there's no common factoring able to be done. So this is a complex trinomial. It's still got that 2, 1, none pattern. And complex trinomial, I don't know how your grade 10 or grade 11 teacher would have taught you. Had you been in my class in grade 10 or 11, I would have taught you the way I'm going to show you here. However, if you remember something called decomposition, feel free to ask me, and I'll be happy to retrain you in that as well. So the first thing you do, and I'm going to scribble here, which I would normally do off to the side, but I want you to see where the numbers come from. You find 2 numbers that multiply to be 2. And then you find 2 numbers that multiply to be 3. So you do front, then back in that order. You carve off a little side space, and then you cross and multiply, and try to make the number that you skipped over, which is the negative 7 in the center. And you can't. So this is not the right combination. So you try again. So 2 times 1 is your only choice for 2, and 3 times 1 is your only choice for 3, but I'm going to flip this upside down. Do not flip both of them upside down, because then you're just doing the entire thing that you did above. Oh, water alarm. You do the question upside down. So now I'm going to carve off that space. If this works, this is our answer. 3 times 2 is 6. 1 times 1 is 1, and I can take those and make -7 if this is negative and this is negative, which means this little negative slides in here, this little negative slides across in here, and these are your two brackets. And because it is 2x squared, we'll need the first numbers to have an x. So I'm just going to shift these down a little bit. This is where I'm slow with the technology. And I'll have a bracket of 2x minus 1 and a bracket of 1x minus 3. You may have done this, especially if you had Miss Mitchell, you may have done this, but you would have done it sideways rather than on the up and down. So if you need me to review any of this, please ask. I'm happy to do it, especially since I don't want you to struggle with factoring the length of this course. Fix it now. The last thing I have to say is, again, you can reverse the brackets. So something I'm going to do at the very start of this course, but not continue, is to tell you how much work has to be done. So each of these questions is worth 1 mark because there is 1 line to take care of. So this is another 1 mark question. And for the record, this is another 1 mark question. And when I give myself enough space, we'll look at the other ones. So I'm going to pull this down and shift these guys out of the way so I have some space. Now we already talked about the fact that D is another simple trinomial. It's got 1, 2, 3 terms, making it a trinomial. And it's simple because it starts with the number 1 or just an x squared or a y squared or an m squared, or whatever the case. This isn't even a trinomial. It's got 2 terms. It's a binomial. It's got a minus sign in between. So this, a reminder from grade 10 or 11, is a difference of squares, meaning that you have to take square roots. So if we take the square root of x squared, the root and the 2 cancel out, and you'll get left with an x. And if you take the square root of the 16, that's a 4. So we found the contents of the bracket, which is x plus 4, x minus 4. So you can tell that this will take plus and minus. When you multiply them together, you will get negative 16. Just as a little thing off to the side, when you have brackets that are exactly the same contents with the opposite signs in between, in case you make it to Jeopardy, those things are called conjugates, just a special name for same brackets, opposite signs. Next question, simple trinomial as discussed. It starts x squared, so we have to start with brackets of x. This time we need 2 numbers that multiply to be 6 that make -5 when we add or subtract. So the only choice would be -3 and -2, which would multiply to be +6, and at the same time add to be -3. 1 mark, 1 line. 1 mark, 1 line. Next question, 1 mark, 1 line. Next question, 1 mark, 1 line. If there were 2 things to do, then I would give you 2 marks. So I'm trying to hint you in the right direction. So this is another complex trinomial. I can tell it's a complex trinomial because it is a trinomial. And in addition to being a trinomial, you can't divide the 6 into the other 2 terms. So you can't remove the number out front. So that makes it complex. So this is another one of the ones where I do scribbling, or if you prefer, ask me to go over the decomposition. We need 2 brackets, and I'm going to do my scribbling off to the side this time. Hopefully I get it right on the first attempt at scribbling. So first number first, 2 numbers that multiply to be 6. I'm going to go with 3 and 2, and then 2 numbers that multiply to be the back, which is 5. I can see this in my head a little bit, so I'm going to try that first. For 5 times 1 is 5. Cross and multiply, cross and multiply. That will make me a positive 7. If my 10 is positive, so the top is positive, and my 3 is negative, so my bottom is negative. It is possible that you do this entire question upside down from me, in which case your brackets are identical but reversed. So bracket number 1, 3x plus 5. X is at the beginning because that's where the x squared was. And second bracket, 2x minus 1. X is at the beginning because that's where the x squareds were. So 1 mark, 1 line. If it was 2 marks, that means you'd probably be able to divide a number out. So now we look at this one, and this isn't a trinomial, so you know it's not one of these guys, and you know it's not one of these guys, so you're thinking maybe it's a difference of squares. But a difference of squares requires you to be able to square root. And you can't square root 5 or 8 or x. The only thing you could square root is this one, and that's not good enough. So this is the hardest kind of question known to man. Oops, let's change my color coding. And that is the dreaded common factoring. So we have to find out what's common to both these terms, or if there were 10 terms, all 10 terms. And the only thing that's common, nothing divides into 5 and 8 at the same time, so the only thing that's common is an x. So we can remove an x, and then in the bracket behind, we take an x out of each of these and say what's left. So the 5's still hanging around, a single x out of 2 of them, a minus sign. The 8's still hanging around, the x has been removed, so we're done. 1 mark, 1 line. So the next 2 questions, because they are not binomials or trinomials, big hint, these are both factoring by grouping. And this is where my apology kicks in about my handwriting with the technology. So I call this like the lightning bolt method. We'll see it again, especially when there's no brackets, like question G. I'm not going to give you a marking scheme quite yet. I know I'd say it's at least 2. But I call it the lightning bolt method because I can split this in half right after term number 2 before the sign and make 2 terms here and 2 terms here, and this sort of looks like a lightning bolt. And then I pretend like it's 2 different questions. So in the first half, ignoring all this stuff back here, in the first half there is a common x, so I can take that out the same way as I did with question F. So I'm left with y plus 6. And in the back half, ignoring all the front stuff, I could take out not just a 5, but a positive 5. I must take a sign with it, and I'm left with a y plus 6. And it is a factoring by grouping question when you don't fake the math and you end up with the brackets exactly the same. When that happens, your next line will be to take the y plus 6, or whatever it happens to be that's duplicated, write it in a bracket out front, and then in a bracket behind, write all the stuff you haven't gathered yet. So that would be the x and the plus 5, which is why that sign is so important. And you're done. So if you FOILed this out, so if you did y times x, it'd be xy, and y times 5 is the 5y, and 6 times x is the 6x, and 6 times 5 is the 30, you would end up with the original question, maybe in a slightly different order, but that is still okay. And that's kind of the point of factoring, is to make as many brackets as you possibly can, to make multiples. So this last question, again, I'm going to say that I'd probably make it out of 2, maybe 3 if I'm feeling generous. I've done the common factoring line for you, but my brackets aren't the same. And that doesn't mean you're unhappy. That just means you have to notice certain things. Like, these brackets are backwards from each other. This B is negative, this one's positive. This A is negative. Sorry, this A is positive, this one is negative. So they're exactly opposite signs from each other. And when that happens, you're allowed to do this. Pick your favorite bracket, which for me is the alphabetical one. Make the other one its reverse, but if you reverse it, you have to reverse that sign as well. Now, we can pull off what we did in G. Your brackets are identical. Whoa! So we can pull the A minus B forward, and in a bracket behind, we have the x minus y. I like the happy faces. Anyhow, I advise you to take a little break right now. Let that sit, and we're going to go on to a next topic, which is another review. So we're just going to keep going. It'll be solving by factoring. Back again with solving by factoring. Hope you took a little break. Oh, did not intend for the happy face. I'm going to do a little bit of babbling. Please know that I did put a little bit of effort into the planning of this note so that it isn't as long as it could be. Here's the start of solving quadratic equations by factoring. First of all, this stuff right here is not a quadratic. A quadratic has a term that is squared and no higher. So this is linear. This is something you would have done in grade 9 and probably a little bit of grade 10. It happened in grade 11 as well, and it'll happen in grade 12. But it's a degree 1 because the highest exponent on any letter is a 1. It just happens to be invisible. That means there is one potential answer. That doesn't mean there's one answer. That means there could be one answer. There could also be no solution. With quadratics, the fact that I have a degree of 2, meaning there is a 2 and no higher, that's now called a quadratic equation instead of a linear equation. Degree of 2, and this has 2 potential answers, meaning that it has 2 answers, or it could have only one answer, or it could have no solution at all. And we just have to see how these things kind of fall into place. So here's how I designed this note. If you take a look at these 2 questions, they are the same as these 2 questions. So what I'm going to do is I'm going to take x squared plus 5x plus 6, and instead, next line, I'm going to write x plus 3 and another bracket of x plus 2, because that's all I can remember at one time. There's the question again. Hopefully you notice there is one little change. And that one little change is that instead of having the equal sign on the left-hand side, we have an equal sign inside the question with a 0 on the right-hand side. And that makes it solvable. So if you stop here, that means you're not done the question. You can't get full marks. You will not have a solution. Solve means that you should end up with 2 different answers. This isn't an answer, and answers that look like x equals a number. Now the way you get that, and I'm going to do it in green, is you take each bracket and you give it its very own 0. This only works for a 0. So if there is a 12 sitting here, you can't pull this off. It must be a 0. So it must be a 0 on the line above. So this makes you happy. This makes you happy. So once you get this, you solve like a linear equation, meaning you take the 3 across the equal sign, and now it's a negative 3. And with this one, you take the 2 across the equal sign, and now it's a negative 2. And this is your answer, your two potential x equals numbers. Not 3, 2 at the very most. And you should technically put a little or in here because you can't have an answer of -3 and of -2 at the same time. So, memory is failing. So I'm going to zip back here for a second. 2x minus 1, x minus 3. Same question. Same factors. Only, huge difference, more work, equals 0. So then I can dig out the green pen. And the reason I do this in green is it's completely optional. If you can do this stuff in your head, you should be getting it right. Do not do it in your head if you continually make a mistake. So with this one, there's a little bit extra work. I have to take the 1 across the equal sign, and it'll be positive. And then I can divide both sides by 2, and I end up with a final answer for one of the brackets of 1/2, positive 1/2. And then this one's pretty easy. If I take the -3 across the equal sign, it's a positive 3. So you can leave out a little bit of writing. And you can leave out this. Most people don't get this wrong. A lot of people screw this up somehow, and I don't want that to happen to you. So look at my planning. Holy smokes. There's another repeat. Only because I am, I'm such a good difference of squareser. Not a word. I'm just going to fire that down. Remember that you could have x minus 4 as a bracket before x plus 4. Don't forget the equal 0. You can't do this unless it's equal 0. This is a problem. So x plus 4 equals 0. X minus 4 equals 0. X equals -4. Or x equals positive 4. You can make this statement, which is only good for conjugates, so it's only good for difference of squares. Next up, this one. Again, I'm pretty good at this, so I don't have to do the old flipping back. I don't know if this was the order of the brackets, but it doesn't matter what order your answers come in. It matters the content of your answers. So far, we're getting 2 answers for 2 potential answers. Again, all this green stuff is optional. If you have the ability to imagine this -3 crossing the equal sign and becoming positive, opposite operations. And if you can imagine this -2 crossing the equal sign, oops, and becoming positive, then you can do that like in your head, and I'm using air quotes right now. So, reminder, this makes you happy, which means this makes you sad. So there's one extra thing to do in this question, and that is to force yourself to be happy. And now, double check. Yep, I'm going to steal my answer. So 3x plus 5, 2x minus 1. 3x plus 5, 2x minus 1. And these are stolen questions, stolen from my first. I will need to see the factoring. So I do need to see the 5 come over to make an equal 0, so this all can happen. I do need to see the factoring. I don't need to see this There's another line of work I'm going to put in, but some people can go from these brackets to x is equal to -5 over 3 or x is equal to positive 1 over 2. In this case, that's how I got that. In this case, that's how I got that. And then, final question of the solving by factoring. So this, notice the instructions: factor fully, factor stop, the end. These questions, solve. It might say solve by factoring, it might just say solve. So this was our common factoring question, which I can do in my head without checking back. Happy we've got the 0. We'll have 5x minus 8 equals 0. Don't lose the x equals 0. This one we've got some fiddling to do. I'm getting messier and messier. So we get an answer of x equals 0, or 8 over 5. Now, if I were you, I'd be taking a mini break right here. I've got one more question, and then we move on to the last little bit, I think. Also a review. I'll leave it there while I pause for a sec. So I'm going to do this question 3 times. Unnecessarily, but oh well. Can't explain why this dude is sitting here. I don't know. Must have had a theme somewhere. Anyhow, so I'm going to start with the most mathy way of doing this question. And the most mathy way of doing this question is noticing that I don't have my equal 0, so I should pull this 100 across the equal sign to make an equal 0. And then I should pretend that the equal 0 isn't there, and I should factor this. So for instance, I can take a 4 out of both these terms. Even though you imagine the equal 0 isn't there, you still have to write it down. And then I notice that this bracket is actually a perfect difference of squares, because I can square root x squared, I can square root 25, and I can force that to be a negative 25 by having my conjugates equal 0. So at no point am I ever going to get rid of the green pen. So 4 equals 0, x plus 5 equals 0, x minus 5 equals 0. This is garbage. 4 does not equal 0. You can't solve for x because there is no x. This, we'll take the 5 across the equal sign. It'll be a negative 5. And in the final part, you have x minus 5, so we're going to take it across the equal sign, and it'll be positive 5. So quadratic, not 3 answers, not even possible, 2 potential answers, and we actually got 2 actual answers. So now I'm going to do the question again. I'm going to do it in purple. And when I do it this way, I'm going to start by fixing it and making sure I have the equal 0. Now some of you might try to proceed with this question without even noticing that there's a common factor, because common factoring is, for some reason, the worst kind of factoring done by man. So if you don't recognize common factoring and you go straight to difference of squares, that means you'll have a bracket of 2x and 2x, which would go back to 4x squared. You have 10 and 10, because 10 times 10 is 100, or the square root of 100 is 10. One's a plus, one's a minus for the conjugate, and the equal 0 so that you can proceed. Then 2x plus 10, give it a 0. 2x minus 10, give it a 0. Take the 10 across, divide by 2, take the 10 across, divide by 2, and we end up with x equals negative 10 divided by 2 can actually be done. 10 divided by 2 can actually be done, and we get the same answer. Ta-da! Those are the most correct ways of doing it. There's another way, it's super dangerous. So I'm going to tell you that it's dangerous. It's dangerous because you don't get the right answer. And it is taking 4x squared equals 100 and not making the 0. Now, you can get the right answer doing this, and I'm going to show you. So step 1, divide by 4, divide by 4. So x squared is equal to 25. And then a lot of people will square root. So a lot of people will get x equals 5, which means we lost half our answers. Which means if you're doing this for a purpose, which is actually what you end up doing, you don't do this for fun. If you're doing this for a purpose, you've lost half your work. So what makes this right and what people forget is that when you square root, or when you take off a little 2, you have to remember that both 5 squared would give you 25, and negative 5 squared would give you 25. So you need the plus minus, and that will give you your answer. So it's dangerous because sometimes people don't do it right. So again, I recommend you pause here for a second, as am I, and we will go on and do the last little bits. So I sort of lied. We have one more thing to do after this. This is more review. The last part may be the non-review for you. This is the quadratic formula. You will need to memorize this, probably for math and science, definitely for math, especially since you're taking math. It should already be memorized, or at least partially memorized, so it's a re-memorization. Some things I want to go over before we tackle the quadratic formula is that this is called the quadratic formula. It's a formula. That's why it's called it. It's only good for quadratics, which is why it's called the quadratic formula. And it's good when you're solving quadratic equations. And quadratic equations look like this. They have to be in order so that the squared term is first. So you have a digit in front of, or invisible, in front of the x squared. You have a digit coming next in front of the x, with or without a sign, and you have a digit at the back, or a constant, and an equal 0. If you don't have the equal 0, and you just have ax squared plus bx plus c, which looks like a simple trinomial or a complex trinomial with no right or left-hand side, you no longer have a quadratic equation because you don't have an equation. You have what's called an expression. And the final thing that you have to keep straight, or it would be wise to keep straight, is if I didn't put an equal 0 on one side and instead either put a y or I put an f at x, you don't have a quadratic equation anymore, and you don't have a quadratic expression anymore. You have what's called a quadratic function, meaning that you can graph it because it's got an x and a y. So you can only use the quadratic equation, the quadratic formula when you've got a quadratic equation. So we've got some quadratic equations here. All but the first one have the equal 0, which is absolutely 100% necessary, just like before when we were solving by factoring. I'm going to take these two questions, which I made movable, and I'm going to shove them on the other page. See if I can get rid of them. And we're going to tackle these guys. So what I like to do every single time is I like to list off to the side my A, B, and C. You can't do that until you have a properly set up quadratic equation. So that means taking these two terms to the other side. I'm choosing to take it all to the left where my x squared is positive. So this has a sign switch and this has a sign switch, sorry, operation switch, and we're leaving 0 behind, and now you're happy. So A is 5, the digit in front of the x squared. B is 2, the digit in front of the x. And C is -4, the constant. One of these may not appear. It shouldn't be the A, because if it's the A, then you don't even have a quadratic. I have something missing on my quadratic formula, and it is the x equals that's supposed to be out front. I chose to pick this graphic, which didn't have the x equals, because sometimes it's not an x and it's an m. So you have to be careful with that. So I chose to leave it out. So I'm going to put the quadratic formula here so I can use it twice. -b plus or minus b squared minus 4ac all over 2a. And then I'm going to work with it here. So x equals -b, so -2 plus minus. -2 has to sit in a bracket because a negative number being squared. Minus 4ac over 2a. So I can do this in my head, which is nothing. I can do this in my head, which is nothing. And this is 84. Now, I do not want you to punch that into your calculator yet. I want you to be able to do reduced radical form. So that's another skill that you should have learned in 10 and or 11. So I'm going to do it right here in my little scribble land. We have to take root 84. We have to divide it by a perfect square. So we have to check if 4 divides in here. So yes, 4 divides in 21 times, so it divides in evenly. We have to see if 9, so 3 times 3, divides in. 9 does not divide in. We have to check if 4 times 4, 16, divides in. 16 does not divide in. 5 times 5, 25, does not divide in evenly. 6 times 6, 36, does not divide in evenly. 7 times 7 does not divide in evenly. 8 times 8 is 64, does not divide in evenly. 64 is more than halfway, so I'm not even going to keep trying. So I go back to the fact that 4 times 21 was 84. And 84 is under a root sign, so 4 and 21 are also under root signs. 4 is special because it was one of our perfect squares, so I put it first. Something can be done with it. Nothing can be done without using your calculator with 21. So I can put that there. And instead of root 84, I can plunk that in its place and repeat everything else. And then the final thing you have to double check is when you look at your very normal numbers, all 3 of them, can you divide them all by the same number? And the answer is yes, you can divide them all by 2. So this divide by 2, this divide by 2 is 1, so I'm going to leave it invisible. And this divide by 2 is 5, and there is your most accurate answer. Yes, you can turn that into 2 decimals, but if the instructions ask you to do reduced radical form, this is what we're after. So let's try it again with this question. Again, I need my A, B, and C. So A is 3, B is the number beside the x, so in this case the m, and there isn't one, so that's a 0. And C is the number without any letters, so that's a positive 75. So I'm going to dump them into the quadratic formula as well. So negative b plus minus b squared minus 4ac over 2a. And no, you don't have to write down the zeros, but I'm doing it anyhow. So I can do this much without a struggle. 4 times 75 is 300. 300 times 3 is 900. So under a root sign is not 900, it's negative 900. And hopefully you learned somewhere between 10 and 11, grade 10 and 11, that negatives under the square root sign don't give you real live graphable numbers, so we have to leave that alone. Sorta. They create imaginary numbers, because if there's no math to be done, we make up more math. And then you try to find a perfect square that divides into 900. Well, the nice thing is if you hit 900 and a square root button on your calculator, it will spit out a very pretty 30. So this is a plus minus 30i over 6. And 30 divides evenly by 6, so I can just make it like that. So we still get two answers. They're just two crappy answers. They're even crappier than these ones, which could be decimals. So if you tried to punch this into your calculator, you could do it. If you tried to punch this into your calculator, you can't, because your calculator will not accept a negative under the square root sign. If you try to punch this into your calculator and actually get a decimal, that means you've done something wrong, because last I checked you don't have an I button on your calculator, and it shouldn't work properly if you do. So that is just a reminder. So we got two more questions with the quadratic formula. We don't have to do them both. We don't have to do either one of them. All my questions aren't 100% necessary. They're just a reminder that things like, we don't have to do this next question, you need an equal 0, but it doesn't matter if you have an equal 0 on the left or if you have an equal 0 on the right. At this point, you can just proceed with a equals 4, b also equals 4, c equals 3, and then with this question, you could do a equals negative 7, b equals 9, c equals negative 1, and you can proceed. Now what I'm going to do is I'm going to pause. And when you come back, if you pause, all of a sudden, all this is going to be filled in with the solutions to these questions so that you have two more examples to work through. All right, so here is your solution in red to this question, which is a question where you end up with a negative under the square root sign, which gives you an I, and I forgot to mention that I's are complex numbers. That's what they're called. They're imaginary numbers, and there is no decimal equivalent. So if you get a decimal answer to this by plugging it into your calculator, that means you are magic and wrong. This question, I just did it here. It's quicker because when you get to the end square root, you end up not being able to break it down like I did in green here for the 32. There is nothing, not 4, not 9, not 16, not 25, 36, 49, etc. So after 49, 64 is 8 times 8, 9 times 9 is 81, 10 times 10 is 100, etc. None of those divide into 53, so you got to leave it. So you could end up taking negative 9 plus the square root of 53 equals, divided by negative 14 equals, and get yourself a real live decimal here. You could also do x equals negative 9 minus root 53 equals at the end of the top, divided by negative 14 equals to get yourself the second decimal. So all these questions are examples of quadratic equations, degree 2 equations that have two potential answers and end up with two actual answers, as opposed to not two answers, so one or none. You will run into, over the course of this course, examples of quadratics where you do not have two potential answers, sorry, you do not have two actual answers. You might have one or you might have none. Oh, I lied. Sorry. Technically, This question here is an example of no answer, no real answer, even though there are still two complex answers. So again, take a little break. Before I continue with the break, here's algebra review from your little booklet. Here is the quadratic formula, which we just finished, from your little booklet. Here's factoring review, so that is different than the extended factoring, the solving by factoring. What we're going to do next is we're going to go back to these two slides right here, and we're going to finish off this, and that stuff right there is sum or difference, so either one of them are the same, of not squares, cubes, meaning that you might want to search for the equivalent of that button on your calculator. So just so you know what we're up against next. This is the stuff that may not be a review. Anyways, take yourself a little break. All right, so sum and difference of cubes or difference of cubes, it's one or the other. They're all based on cubes. This is a cube that you can cube root. This 3 times 3 times 3 can be cube rooted. 8 is 2 times 2 times 2. 125 is 5 times 5 times 5. So they're all cube rootable numbers, in case that's an actual word. This is a difference of cubes because it's got a minus sign. This is a sum of cubes because it's got a plus sign. This is unlike difference of squares. Difference of squares must have a minus sign. There is no such thing as sum of squares. So this is one or the other, which is why it's sometimes left out of grade 11, and in the case of online learning in a pandemic, it probably was. So what I'm going to do is I'm going to move B out of the way just a little bit. We're going to work with A, which just happens to be a sum of cubes because it's got the plus sign. And I'm going to work through these. Now, this was a box of information that was in my high school textbook. You can probably find it online. It made absolutely no sense to me. So instead, I'm going to show you what I came up with, and then maybe we can work backwards and explain this to you. So there's a whole lot of scribbling here, and I do apologize for that, but you're going to have to kind of get over it. So the first thing is I'm going to take the cube root of x cubed, which is x. So that's this position, which is this position, and that fits in this tiny binomial size bracket. Then I take the cube root of 27, 3 times 3 times 3, and I put that here. So you can see that. You can also see it here if you ignore the signs. So now my scribbling begins to create the trinomial size bracket at the back. So let me leave some space. I hope it's enough. And I take this thing, I put it there, but in order to do that, I have to do what's in this box, which is take that and square it. So x squared is x squared. Genius. Then, same thing here. This gets squared and put at the back. Three squared is 9. Then you take those two things, so in this case the A and the B, notice how I don't have any signs in there, and you smush them together and you put them here. That means you multiply. So in this case, x times 3 is 3x. Sometimes you have a little more work to do than that. And then you'll notice that the plus for us stays a plus. Then you have a minus. Then you have a plus, according to this. Now what I say in my head every single time is keep it change it, always plus. So you keep it, you change it, then it's always plus. Other people I've seen online is soap, so same, opposite, always plus. Your choice. So now I'm going to do it with a difference of cubes. I'm going to follow the same pattern, and we're going to do it the same way without all the color coding. If you need to take a break, now is a good place to do it. In fact, you can take a break whenever you want. So, not as much scribbling this time. I know it's a cube because they're not square rootable numbers, they're cube rootable numbers. It doesn't matter if it's a plus or minus, it always works the same. So if I take the cube root of 64, I have to figure out what number times itself 3 times is 64. That's a 4. Cube root of x cubed is x. I like taking that and squaring both of them right away before it clogs my brain. Cube root of 125. Cube root of y cubed. I like to take that and square both of them before I clog my brain. And then multiply them together, so 4 times 5, x times y. And just for fun, a color change. Keep it, change it, always plus. The end. This is a 1-mark question, as was the one above it. The thing is, that bracket, although it looks quite a bit like a complex trinomial, is not factorable, so you will get to stop. So next question. 3 more. Take a break if you need it. Just so you know, this is a 2-mark question. This is a 1-mark question. I'll let you know this. I can't preview too much in my head at the same time. So you take a break. I will not. So what makes this a 2-mark question, now that you've come back, is the fact that I can't cube root 24 or 3 and not end up with a decimal. So instead, I have to go looking for something else to do for my 2nd mark, and it is that I can divide both terms by 3. There's no letters common, so this is the dreaded common factoring. So I end up with 3 into 24 is 8, letters stay the same, plus 3 into 3 is 1, letters stay the same. And don't know why I did that. Now I can leave my 3 and set up my binomial and trinomial size bracket. So 2 is the cube root of 8. The cube root of x to the 6, divide by 3 on the exponents. So that makes this 4x to the 4. Like I said, divide by 3. Wish I could undo. Then multiply them together in the center. Keep it, change it, always plus. Now, what I want you to see in this scary looking question is it doesn't matter how the numbers and letters are set up. Don't get freaked out by fractions, pretty please. Binomial, trinomial. 8 is 2 times 2 times 2. X cubed, divide by 3. Here's the tricky part. Not yet. Now the tricky part. 1 times 1 times 1. 3 times 3 times 3. 1 squared, 3 squared. Multiply them together, gives you 2/3 x. Keep it, change it, always plus. Oops, I'll give you a sec there. Pause if you need to. Review if you need to. Ask me questions through email, in person if you have that ability to, or through Edsby. Somehow get in touch with me. to straighten you out if you need straightening out. Just because I explained it this way doesn't mean there's not another way for me to explain. So last question, I'm going to do it in purple just for fun. I know this is at least 2 marks, maybe more, so I'll leave a little space in there. Binomial, trinomial. Like I said, when you're cube rooting exponents, just divide by 3. So that's 4. And it's a 4, mixing things up. Square, square. 4 of these and 8 of these goes back to 12 of these, so I haven't screwed this up yet. And then multiply them together in the center, which is just a smush. Keep it, change it, always plus. Where is the second mark coming from? Well, the second mark can't come from me factoring this, because I've already said it's unfactorable. So it must be this guy here that's creating all the problems. Now, if you take a look at that, that is a difference of squares. So x squared minus sign, so that gives me a plus and a minus. Y squared. And then don't forget this baby out back. My hand is cramping, which is why my handwriting is getting worse and worse. So you know this is a 3-mark question. Where on earth would the third mark come from? So not this. We've already discussed that this is not factorable. This is not a difference of squares because it's not a difference. This is it. So concentrate on what you can do. So I can do this, x plus y, x minus y. So there's my difference of squares taken care of. Do not lose all the other parts. So don't forget to rewrite this, which is untouchable, and don't forget to rewrite this, which is untouchable. And then you're done. And like I said, you can pause this at any time. You can review any of this. This is a fairly long note. It's probably the equivalent of 3 on a normal day. And you can do as much or as little, knowing that this stuff lasts the entire course, so this will not go away. This should be the only real new stuff, and there's not much to that. It is in your booklet, and your booklet is either in your binder, because I gave it to you, or it's online on that Google site page. So best of luck. Ask me lots of questions. That's what I'm here for. Oh my gosh, I've kept this to under an hour. This is a miracle. I should probably just talk for another 2 minutes, but I'll save you that. Bye.